which I've done twice before about speaking. So, very clumsy. All right, so this is Kubernetes learning from zero to production. Who here has heard of Kubernetes? Okay, fair number of people. Who here has used Kubernetes? Use meaning like any sense of the word. You could have done it on your laptop at this point, you know. All right, so I'm here to talk about basically what happens when you have to learn it from zero to production. And a little bit about myself. I am a thought worker. I have use of this lovely space, but I'm not based here in Dallas. I'm based out of New York. So I am what they call an infrastructure consultant. My primary goal is to help any customer or client who's looking to get from their data center to cloud, anything they're trying to do with automating their data center, automating their cloud, automating, I don't know, containers, for example. So that's where Kubernetes comes in. I've had the distinct honor of deploying every single container orchestrator to production except for one. And if you can guess that one, then I have no prize, but you get kudos, right? And so I'm a harbinger of donuts and chaos, mostly because I like donuts. But also, I'm someone who really enjoys systems. I really enjoy looking at operating parts of systems and understanding how to really operationalize and put them in production. My handle is Jack of all trades, master of none, 08. That's one way you can remember it. You can find me on Twitter, Medium, LinkedIn, et cetera, et cetera, et cetera. And this is kind of cool because I actually did my first public speaking talk at a Women Who Code meetup. That was about a year and a half, 2 years ago. And since then, it's been really great because I got that first practice, and I've just been kind of public speaking ever since. So it was a really fantastic opportunity. If you're curious, my original talk was there. I had a certain lack of color and a lack of creativity when it came to font. But it was pretty useful. All right, so what's the story? Why am I standing up here talking to you about Kubernetes today? Well, it started with 3 simple words. Build a platform. Okay, my first question was, what's a platform? I don't really know what you mean, because platforms could mean anything. I could be standing on a platform, and that could be the same thing that a client is talking about. So I started to narrow it down. I started to talk to a lot of people within this client, and I said, okay, what do you need? And they said, well, we need 3 things. First, we need it hosted on public cloud. For a while now, we've been putting stuff in the data center. We're not really using it to the best of our ability. Things are going down. We don't like it. Let's move to public cloud. In this case, we were using AWS because there was actually certification paths within the organization to do AWS, and they had already cleared it from a compliance standpoint. So we were like, all right, let's do it. The second is to avoid vendor lock-in as an architectural principle. So if you commit to a vendor, you want to avoid locking yourself to it, right? So if you, for some reason, change something, or you decide you want to use GCP, Google Cloud Platform instead, you don't want to be subject to all of the nuances and trying to figure out how to port everything over. So what we tried to do was say, okay, let's use Kubernetes to schedule workloads. The reason why is that a lot of the public cloud providers have Kubernetes out of the box today. It's backed by the Cloud Native Computing Foundation, so it's a very open source community. A lot of people are committing to it. And there is some level of support on each public cloud platform. Makes a lot of sense, right? But then there's the third piece, right? Use software as a service products when available. So software as a service means that if I need something like metrics, monitoring, I can just get it out of the box. And yes, it's a little bit more expensive, but the problem was that there was actually a really small development team. Like a team of 3 security engineers were managing a huge footprint, and then a team of about like 5 or 6 infrastructure engineers were managing all of the systems in this firm, right? And that's a lot for very few people. We couldn't really afford to build and develop and build our own. So that's why we said, okay, we'll use software as a service. But then we kind of ran into a problem. On AWS, the Kubernetes service wasn't available at the time. So we were like, oh, what do? We don't really want to sit there maintaining Kubernetes. We don't want to like install stuff on servers. That's just terrible, awful. I don't want to do that. No one wants to do that. So we had to figure out something. I'll talk about what we did. But the difficult part really wasn't Kubernetes. The really difficult part was building capability because no one in the firm had ever used Kubernetes before. And so what we figured out was that capability is really difficult to build because you don't really know where to start. You don't really know because you don't actually know what's actually useful, right? Knowledge and search and relevance, which is something I learned recently, is a very nuanced kind of field. And if you don't know what you're looking for, how do you know where to start? So then, the last question was, how do you run it in production if you've never actually touched it before? It's pretty intimidating, right? On top of that, of course, is the usual constraints. Time, you must get this done. And then the developer capacity I mentioned before, we pretty much only had a pool of 8 people to choose from, and actually we were told they only had a maximum of 25% capacity, which meant that they could only commit 25% of their time to the project, which does not add up to 100% if you accumulate across 8 developers, right? It doesn't work that way. So then, on top of that, we were actually developing a product. So there was actually an application or a set of applications that had to go on top of Kubernetes. So with all of these things, we were really terrified. We pretty much almost broke down in tears. And then we saw the search results for learning Kubernetes. So it's about 13 million to learn Kubernetes. This was actually, I think, like October. And then Kubernetes in production was about 5 million, probably about 5 million now. You probably couldn't read through all of this, right? It's just not feasible. So what I figured out was, like, I don't need to be an expert in any of this. And I think that's really easy for you to get into a mindset of, I need to be perfect, I need to know all of this, I need to be production ready right off the bat. And the reality is that's not the case. I just need to know enough. And if things don't work or they have to change, I pivot. I have to be really flexible and pivot. I have to be the expert at pivoting, but not the expert at Kubernetes. So this is that story. This is my table of contents. It's long. I promise you there's a break in the middle. And it's kind of a brain dump of all of the things we learned. But the thing is, when you look at this, it's boiled down to the problems we ran into and how we organically found something in Kubernetes that could address the problem. So all of these things were the things we learned in order as we started to build our cluster. And I'll talk a little bit about what was kind of left over and some future investigations. But I'm going to walk through all of these constructs and kind of the problems they were solving in that moment. And hopefully you'll understand zero to production, at least somewhat. All right, I will ask you to suspend your disbelief just a little bit. I'm not going to talk about the business case behind Kubernetes because that's a whole talk on itself. I'm also not going to do all the internals. I'm not going to do troubleshooting. I'm not going to talk about chaos testing Kubernetes. If you're curious about that, please feel free to ask. And I'm not going to talk about advanced key value stores or any of the other likes that might have been hosted in said platform. So if you have questions, please wait until the end. It's pretty dense, so write it down, or you can feel free to message me anytime. And if you want the slides, check Meetup or Twitter. They'll certainly be up, and there's a recording too. Alrighty, now we get started with good stuff. The prologue. What is Kubernetes? So for those who haven't really worked with Kubernetes before, there's a concept called Docker container, not concept, but there's a technology called Docker containers. The idea is that you can abstract away certain resources on your system and hem it off. It's fenced off. And that says, hey, all those resources belong to an application. And what's the beautiful thing about having containers is that you can install all your dependencies, you can install all the things you need without needing to actually sit there and type it all out. So how many people have gotten a new laptop and spent a day trying to install everything on it? A lot of people, right? So containers kind of take away that pain, which is kind of nice. But then you start to have a lot of containers. Like I found probably about 100 containers running on my local laptop at one point because I just never bothered to clean them up. And so then eventually you get like this, right? Where you have 3 people having tons and tons of containers on their laptops, and then you have eventually servers in the data center, servers in AWS, servers in Google that have all these containers. And all of a sudden it's kind of like a kindergarten class run amok with no teacher. So you're like, all right, something's gotta happen, right? So, good question, right? How do we manage these containers? Is it A, we group them, B, we write some code to schedule them on resources, we C, build some connectivity to bridge them all together, or D, we identify them in a human-friendly way? All right, who thinks it's A? This is A. B? C? Got some hesitancies? Yeah? D? All right, trick question right off the bat. It's actually all very fun. So the idea is that all of these concerns are handled by what you call a container orchestrator. And that is what Kubernetes is. It sits and it orchestrates all these containers, helps you group them, write some code, build some connectivity, and identify them for you. So it manages it. It's nice, right? All right, so under the hood. I'm going to get really simple with the under the hood. There are a lot of other components and pieces and protocols and nuances, but we're going to boil it down to some simple concepts. So Kubernetes itself, as an orchestrator, has a master and a node architecture. So the masters contain important components like an API server for you to do calls against to say, hey, put a container somewhere. Or there's also etcd. etcd is a key value store technology, and what that will do is store the Kubernetes configuration. Sounds okay so far. All right, scheduler schedules nodes, or schedules pods on nodes. I'll talk about pods, but the idea is it schedules things for you. And then the controller manages them. So if something is dying, something's bad, something's not great, controller will go back and fix it. Okay. Masters, pretty simple. Nodes, on the other hand, have a couple of other pieces on it. You can keep adding. So there's usually something called a kubelet. There's actually always something called a kubelet. That's the agent that talks back to the master. So it reports back to master and says, hey, I'm here, I'm on duty, I have X number of containers. You've also got kubeproxy. Kubeproxy takes requests that comes in and forwards it to the right container. So it's basically proxying all of the requests. And then you've got your container runtime. So as I mentioned before, Docker is a container technology. It's probably the more popular one today, but you have to put the runtime onto the machines. Otherwise, you can't actually create containers. All right. So if you're curious to learn more, I always include links at the bottom. So as you get the slides, feel free to just dig into the links. All right, so we got the prologue out of the way. And finally, we're like, all right, we understand the architecture of Kubernetes, kind of. And now I'm ready to put it on my laptop. So there's something called MiniCube. The question is, what is MiniCube? Is it A, a fun-sized microcontroller distributed on Halloween? B, a tool to deploy a local Kubernetes cluster? C, a packing cube that compresses garments, very important? Or D, an alias for famous hip-hop star Lil Peep? Who thinks it's A? Who thinks it's B? Who thinks it's C? And who thinks it's D? I want it to be A, but it's not. It's a tool to deploy a local Kubernetes cluster. Actually, someone actually named themselves Little Cube on my team at one point. So it's a tool that deploys a local one on your laptop. And it looks something like this. The idea is that as you type, you're going to say, I'm going to build my MiniCube, I'm going to build a container, I'm going to actually run it on there, and then I'm going to get deployments, and all is well with the world. This is a great tutorial. I've learned all that I needed to know about Kubernetes from this fabulous link that's called Hello MiniCube. I have no clue what any of this means, right? So at this point, I'm like, oh, great, lovely. I just accessed my application, but I don't actually know what I did. So let's boil down what we actually did. So you noticed in that sequence of things, there was something called deployments. You were getting some stuff, right? And it was saying like you got 1, 2, 3, 4. So what is a deployment? Well, in order to explain a deployment, I have to explain another construct, which is called a pod. In Kubernetes, a pod is the smallest construct, right? It's the smallest unit of a service. Think of a deployment usually containing a container, or a pod having a container. So a container is small, but groups of containers can do a lot of things, right? So you can specify a pod specification, and what that pod specification will do is say, give me a container, right? And it should be on port this, and I want volumes or et cetera, et cetera, et cetera. The idea is it basically declares connectivity between groups of containers. There are other container orchestrators that do this a little differently. They don't use pods, they use just the plain old containers. But the reason why pods are really nice is that you can actually have shared volumes, shared storage, shared memory. So the idea is that it's an easier construct to consume. So pods are these kind of like hexagon things. All right, so what are deployments? Deployments tend to be the most commonly used construct in Kubernetes. What basically a deployment does is say, okay, I want 2 pods. So remember, we had the pods before with container XYZ, container ABC, and now I want 2 of them. So deployment says, give me 2 of these pods, which is nice, right? The idea behind deployments is that it's backed by something called a Kubernetes reconciliation loop. So if one of those pods, let's say this one, goes down, the reconciliation loop will trigger and bring it back up. So a deployment is basically, you can think of, the number of instances of your application. The pod itself is everything you need to run your application, while a deployment is the number of instances you might need. So you kind of build up from there. But after you've got the initial deployment, you run it on MiniCube, you now have to put it in the cloud. And in this particular segment, I want to talk about Kubernetes Offs. I'll explain a little bit about what that is, but I'll also go into EKS, which is the managed service as well for AWS. All right, so there are a lot of ways to put Kubernetes on the cloud. And some of them don't work for everyone, right? So there were about 47 on the list as of January 2019 when I was like counting through it. So there are a lot of ways you can do it, a lot of guides, a lot of pros and cons to each way. So at the time when we were actually implementing Kubernetes, we said, well, we don't have EKS. We need something that will deploy a Kubernetes cluster to AWS. And there was a community tool called Kubernetes Offs, or COFs at the time. It was really nice because it did create, read, update, delete. It was very, very simple. Very interesting constructs behind it, and it handled a lot of good things like configuration. We could do multiple masters. We could put up what you would call a bastion for security, so the bastion is like a jump box, so it allows you to access for debugging. We actually did away with that later on, but just to get familiarity. We could declare that within Kubernetes Offs. And we could do dry runs. So it would tell us if we made changes, these are the changes that you would be applying, and this is a problem or this isn't the problem. So it was a really powerful community tool. And if you actually run through it, you're basically going to say, create me a cluster. I'm going to create something on AWS in US West 2, blah, 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 et cetera, et cetera. It starts making changes. And what I'm going to do is then update it, and I'm going to actually apply it, right? And it will tell me, you know, it's starting 5 minutes later, then I have a cluster. And I can actually validate it using the same exact. So the idea is that I can actually see all of the things that are ready, what's available, what's not available, and it does it all for me. But the beautiful thing about Kubernetes Offs is that we could actually put it in a pipeline. So if you're actually doing continuous delivery, what we were doing was making changes to our Kubernetes cluster and then pushing it through this pipeline. So we never actually had to sit there and configure anything on the box. Everything was done as code, so we just pushed a git, and then it starts triggering it and rebuilding it. So we would dry run it, and this dry run stage, we would make sure that things were good to go, everything was nice, we didn't have any red flags of like things that might conflict. Then we apply it, and then we actually wrote a bunch of tests. A lot of tests to make sure it worked. So we had our own tests, and we had Kubernetes conformance tests out of the box. Sonobui is a product it's a free actually tool that will actually scan it to make sure it's conformant. And conformance means that it's good for benchmarking. So it's there, it's not necessarily secure, but it all works. So we made sure to put a lot of tests. These are what actually saved us. So if you're to do this in EKS, what would actually look like? EKS is actually the Elastic Kubernetes service, and that's in AWS. So AWS offers this nice experience where you can say, give me a cluster. Google has GKE, Google Kubernetes. Queue. We had assumed that they would scale based on requests, which generates CPU. So then we were like, oh, that is a nuance we didn't realize. Out of the box, Pod Autoscaler scales by CPU. So now you have to write custom stuff to allow it to scale, and you have to tune an algorithm to pull it based on the polling from the queue, right? How many are going to queue? They actually have some code out there now for that. So if you're curious, you can take a look. It was a very interesting nuance, right? Application architecture can kind of dictate the kind of scaling or the kinds of assumptions you make in your infrastructure. Pretty cool. Oh, testing. So I love testing. As I mentioned before, testing saves a lot of things. And at the time, we were really focusing on testing applications. We were focusing on testing everything, logging, how it scales, what scales. And we were like, well, how do we do testing? Because we had this kind of weird problem. Our CI server, our continuous integration server, was external to the cluster. It wasn't actually together, right? They weren't in one network. So it wasn't like we could kind of go from the CI server to the cluster. It was actually over public internet, which security was like, freaked out. And so we were like, okay, fine. Well, it's encrypted. We encrypt in transit. We would go through the load balancer to the Kubernetes API server. We restricted the load balancer. We did a lot of the due diligence and security. But when you test something, it's not like you can run the test on the CI server and just kind of go to the app, right? It's not connecting that way. We tried to isolate the application to prevent someone from kind of breaking into the container and then basically doing weird stuff on our host. So what did we do? Well, we tried kubeproxy, and kubeproxy is exactly what it sounds like. You just inject yourself as a proxy and then just start running requests. Bad pattern. Awful pattern. And it has some latency issues too. So then we were like, all right, well, we can tell everybody exec into your pods, right? Like this is kind of like an SSH. which we're like, oh no, we said we wouldn't let anybody SSH into hosts. Why would we let them SSH into pods? That just seems kind of counterintuitive. So then we were like, there has to be a construct that exists to handle this. And that's what jobs do. So jobs are exactly what they sound like. You run it, and then they just... So job runs like this. Test job is inserted into the cluster and actually runs against the application, and then it dies. And that's it. And so then you can get the results back from that pod. You actually get a nice set of reports sometimes. You can export it to wherever you want to. But the idea is that it's a short-lived job. It runs against it. Security is not being compromised because we're not actually running it externally. So it was actually a pretty cool pattern. We did it for all of our tests, and actually if you work with Helm, which is another Kubernetes kind of package manager, it will basically actually do some of these kind of things, which is pretty interesting. All right. Speaking of security, so good enough security, right? There's never such a thing as good enough, right? Everybody must be like really aggressive about trying to figure out their security. And of course we had to do the usual stuff. Dog eating pizza. So security groups, thanks to Kubernetes operations, we actually had that pretty much locked down, so it's good. And security groups basically restrict the networks and the ports, right, that you can access them. We also had load balancer restrictions. As I mentioned before, there was a lot of concern around transmitting data over the public internet. So what we did was we locked it down to specific places on the public internet that it could only come from. So it's not like everybody on the public internet could access our cluster. Yeah, we whitelisted. So then internal load balancers are another interesting thing. So we tried to ensure that every load balancer that we could was completely internal, so it wasn't publicly accessible, right? And then we made sure private networks, meaning it's all locked down. Identity access management, so who can access the cluster. We did API authorization as a service. I have a colleague who has a fantastic talk about that. I did not link it, but feel free to go look it up. Just type in API authorization. Primitive Kubernetes role-based access control. That means like who can access the cluster, how you restrict them from doing other things. We had the basics, but I think we could have gone actually a lot more in depth, especially with the services themselves, what they actually needed. So you can control who has what volumes and how. And we did not have dashboard. And everybody was like, oh, you don't have a dashboard, how are we supposed to see everything? But we're like, oh, we funneled all the metrics to this other beautiful dashboard over here. And so that way you don't have to go into the cluster and look at the out-of-the-box dashboard. There's actually a security vulnerability on the dashboard where anybody can type in any name and it will just log you in. And this is what actually happened to some companies. Their secrets were actually exposed. So yeah, no dashboard. Felt very Edna mode in that moment. So secrets management. This is a really interesting topic because you do need some way of managing your secrets, encrypting them, making sure that you can securely access them in your application. This is important for databases. This is important for API tokens, right? So initially we went with a product called Vault. HashiCorp Vault, fantastic product. It's like basically this nice little secret management store that you can put in the cluster. But we ran into an issue. Remember when I said there were probably only like 3 security engineers and there were about 5 infrastructure engineers? It's a tough thing to operate, right? Because you have to make sure it's always there, but you also have to make sure it's secure. You have to make sure that people have tokens, people have the right things to do. And the other part is that if it goes down, it locks itself. It like self-seals. And so you have something called unseal keys that are like the nuclear launch codes. And guess what? No one would take nuclear launch codes. No one, right? We were like, hey, you can have this nuclear launch code, and that way you can like unseal our vault, right? If like something really bad happens, and you have the authority to do it. No one wanted it. So we're like, oh, well then that kind of put a kibosh on this whole thing. And we also had a lot of time constraints. So we were trying to do a lot of chaos testing to make sure it was always available. It was a lot of work. So we said, all right, we cannot self-manage our secrets because clearly no one wants these launch codes, no one wants to manage this. So what we did instead was use AWS's key management store and parameter store. So basically it encrypts the secrets for us and then we can just pull it. And that's it. It's always available, it's always there, so we can always just pull it. And what we did was actually inject that as a Kubernetes secret, encrypted, and then put it as an environment variable. And so the nice part about this is that we control the access by AWS, which is kind of nice. And we actually had an encrypted backend, and we injected it at the pipeline. So the deployment pipeline, we inserted it. That had some downfalls in some respects, but for the most part, it worked. especially because we didn't actually have to sit there and manage it ourselves. So that was the benefit. On top of that, our security team said, you have to scan everything, scan all the things. And I was like, oh, the scanning takes so long. So what we actually did was we tried to move to containers that had fewer vulnerabilities. Nowadays, Alpine has vulnerabilities, but it's pretty stripped down. So Alpine Linux is a container-based image, and it's pretty minimal. So you can just scan it, and most of the time, nothing really comes up. It tends to come up clean. Packages may actually trigger, and anything with kernel-level dependencies. So for example, I learned how to unpackage journal D logs and like strip them from binary to string and then regular expression. It was very strange. But basically, it was just to omit the kernel-level dependency that would allow someone to tunnel back into this container and then compromise basically all of our logging. So that was an interesting problem with that. The other piece was actually securing the virtual machines. So what we did was use a CIS hardened image based on Ubuntu. This was a lot of work. The Kubernetes operations comes with a Debian image, and the Debian Linux image had a lot of vulnerabilities. It actually had a really high and critical one, like Spectre, and we were really concerned about that, or at least the security team was. And so they asked us to remediate it. So our response was, okay, we'll go to a CIS, which is the Center for Information Security benchmark, and we'll make sure it's clean. So it was actually a clean image. The tests actually saved us, right? Because it actually broke functionality, Kubernetes functionality. If you're curious to know what, please feel free to ask. The hint is MTU frame sizes. The only reason why I knew the answer to it was because I worked on software-defined networking, and that thing was like, yeah, that was the only reason why I knew the root cause. So it's weird. So make sure you have tests that actually cover the functionality because things may actually break completely. Speaking of security, Kubernetes had its first high vulnerability in December. Oh, November, December. And basically this allowed someone to go into the API server, the master, and compromise all the things, right? Not good. And so there were certain versions of Kubernetes that this had been patched for and wasn't going to be a problem. So we had a little issue. We had to upgrade our cluster because it didn't actually have any of the versions that were listed. How are we going to upgrade the cluster? And so people were agonizing, like, oh man, like, we have to upgrade it, we're freaking out. And then our entire team was like, no, we got this. We actually just clicked changed one line and then clicked the button and everything went right through. So how does this work and why were we not that concerned? Well, when you do a rolling upgrade, the idea is that you're going to say, all right, I'm going to cord in a node, I'm going to put it in quarantine. And what I'm going to do is reschedule it across to other nodes. So anything that's on the node gets rescheduled elsewhere, right? So slowly, it just starts to take everything off, it drains it moves it elsewhere, and now you've got a clean node that you can now say, it's good to go, take it down, goodbye node, bring up the new one. So the idea was that we were never actually doing anything to the applications themselves. It was actually a graceful drain, so it would wait for sessions or whatever parameter we decided to disconnect and then reschedule. So, still available. Pretty awesome. And if you want to DIY it yourself, I think EKS also has this capability to do it. If you actually did this in the pipeline, you record in, drain, delete, and validate, and these end-to-end tests were fantastic. We just kind of pushed a button and waited for all of it to run. We let it run, and 3 hours later, we actually had confirmation whether or not anything broke during the upgrade. And we had some pretty good test coverage. So it actually saved us from sitting there and manually inspecting things. The great part is that when we actually did push an image, and we fixed the functionality, but there was another piece of function that broke, we didn't realize. And it took down, I think it basically didn't allow some people to schedule some stuff. We actually just rolled it back in about 20 minutes. So the idea is that it's very flexible. You can roll back, roll forward, all of the above. And so the end-to-end tests, what were they? What was in them? We tested DNS. DNS was really important to us because we had to refer back to the data center. So we had some really specific DNS resolution. Multiple sizes of payloads. This is what I was talking about, MTU sizes. If you ever get a situation where you do a post request or a get request over 1,500 bytes and they don't complete, it's likely because your MTU size on your node is set to 1,500 and you need to change the headers because Calico has additional headers. Anyway, Feel free to ask questions afterward if you're curious to learn more. But we actually ended up having a whole battery just to test different sizes to make sure we were actually setting all the parameters correctly. And then the service with load balancer. Can we still do that? Can we still deploy it? Can we still reach it? Do we break some security rules or something? And then auto scaling. We had to make sure it's not broken. That took a long time. So we actually run them once a week. So it took about 60 minutes to run a whole set of auto scaling tests to scale up, scale down, checking that everything's good. All right, we're almost there. Goodbye, cluster. So things went really south once when we were practicing for production. We were doing war games. So if you haven't heard of war games or game days, basically the idea is that you mock a disastrous thing in production. In this case, we blew up the cluster. It went really south. No one could schedule anything. It was just not great. And so we were like, all right, well, we didn't think this part through. We blew it away, but then we couldn't recover it. And it took 3 hours. Yeah, 3 hours. It was just like too long. And we were like, guys, gotta be something better. So we decided, all right, we're gonna look into 2 types of solutions. The first was etcd, which is, remember, the key value store that holds the configuration. etcd backups, such a pain. etcd restores, also a pain. So what we looked at was actually something called heptio-arc. It's an open source tool, and what it'll do is back it up for you. So it effectively checks, it's a pod in itself. It checks what's running and then stores it in S3. And then when you want to tell it to restore to any cluster, or the old cluster, it's a restore from the latest backup, gets the latest backup, and then it recreates it. Done. And I think it did that in like 30 minutes. So it was like 3 hours to 30 minutes. We're happy now. So we blew up the cluster a lot. All right, so we've been blowing up clusters. We've been doing all these operating things. It scales up, it scales down, it self-heals. It does all these lovely things. We're pretty hands-off. We're a team of 5 people who have to like sit and look at this, right? So what's still in backlog? What are things that we could improve on? Well, there's always more security, right? So which of the following would not give us more security? Is it A, ephemeral VMs, bastions, masters, and nodes? B, cats on a turntable? C, pod security policy, or D, network policy? I think everybody can kind of guess.
A.
Yes, A. Cats on the turntable. So briefly what all these things are is like ephemeral VMs. Imagine if an attacker got into a host, right? And if the host was really short-lived, like it was only 30 minutes, how much damage could an attacker do in 30 minutes? And so the idea was that we would rotate these every 30 minutes, like take down, the bastion never existed, we actually took them all away, but like if you were to say, okay, worker nodes, they only exist every 30 minutes and they come back up. Keeps it fresh, keeps an attacker from doing it, right? So then pod security policy is a Kubernetes construct you can turn on. What that will do is say, enforce these rules on these pods. So you are not allowed to schedule a pod if it doesn't conform to this security context, this security context, this. Helpful hint, there was a CVE that came out for Docker Run C a couple of days ago. If you applied a pod security policy and enforced it in your cluster, you probably patched for that Run C vulnerability. Cool, so tap a note. Network policy. So the network policy is how do things talk to each other? Can they talk to each other? Can they not talk to each other? We talked about whitelisting before. The idea is that deny everything and some things are allowed. So this is a construct you can use for inside the cluster. So if you're in the cluster, you can use that. And just cancel it. All right, so I'm going to not go through all of these things here, but the idea was that there were a lot of things we did explore after this fact, right? There was more pod security, even more. So that's some information there. Ingress controller we actually did end up doing, and then I actually found patterns for Nginx and ALB, which is kind of nice to do. Kubernetes operators, I attempted to write my own operator, questionably. It kind of went well, but the idea is operators allow you to like plug into the Kubernetes API. So it kind of auto does things for you. You can code it to auto do things for you. Remember that reconciliation loop? Basically, you take advantage of that reconciliation loop for all the things. Kubernetes Helm is another thing I mentioned before. We did Kubernetes security scanning using Kubench. Sidecars for handling certificates we didn't get to, we really wanted to. Kubernetes OIDC, basically for plugging in for single sign-on to Kubernetes. For users, secrets management, maybe we'd go back to doing Vault. I'm not sure, given the current team size, if we would have gone back and do it. I don't think we would have been able to manage it. And then secrets injection via init containers. Basically inject it at runtime when they come up rather than through pipeline, so you always get fresh secrets. It's easier for rotation. So manage Kubernetes. At one point I did do kind of an investigation, did you need to manage Kubernetes? Kubernetes, and some problems that we had did go away. The autoscaler, although it questionably worked. Virtual machine images, kind of the management of it, what kind of went away, kind of. And then continuous integration in the cluster, like deploying Spinnaker into it. That was an option. Some questions don't, like role-based access control, secrets, resiliency testing. You can't get away with not doing some resiliency testing, and testing applications and components. All the patterns still held. So managed Kubernetes didn't really take away those concerns. All right, we're at it. Conclusion-ish, right? Because I'm always still learning. Did we learn enough? Well, at the time, I guess we kind of did. The good news is we never heard we were blocking a deployment to production, which is actually pretty magical because I had never heard that in my career up to this point, that we were not blocking a push to production. So that's pretty cool. And the good news is we actually made it to production. There are things that are happening on it, so thank goodness. There are actually transactions running through it. There are a lot of interesting things, and they're extending it to this day. All right, so kind of at the end of it all, there's a lot in the Kubernetes ecosystem. I just went through a whole list of tools, and you're probably like, Rosemary, that was way too much. Like, goodness gosh, like, why did you do this? I'm like, all right, well, go back to it. If you really need some references, you can feel free to go back to it and see what it is, right? But there's a lot in the community. And the community is a really powerful resource. It's surprising how evolved it has become, especially for Kubernetes. There are a lot of ways you can ask questions, and you don't actually have to belong to the same company as someone else. Be hands-on. I know that it's hard to do it sometimes. It's hard if you're not doing it day to day, but try it. Just experiment. Don't worry about saying that it's right, but just try it for a second. And expertise is in the ability to learn. I think I mentioned before I became an expert in pivoting if something didn't work, and I think that to learn it all was part of the expertise. And just to show you, I'm still not a Kubernetes expert. I've been pronouncing Kubernetes wrong this entire time. The Greek pronunciation is Kubernetes. So I've been saying it wrong the entire time, and all the Kubernetes experts have probably also been saying it wrong the entire time. All right, thank you everybody.